Welcome to the third lesson in Session 3 on the natural logarithm. Similar to pi, the number e is an irrational constant with an approximate value of 2.718. E is a value that shows up naturally in many branches of math and science, which is why it's important. Now, when e is expressed as the base of a logarithm, it's referred to as the natural log. So we have a common log, which is a log with base 10. Now we're introducing the natural log, and the natural log has a base e. It's even given its own notation. So the notation for natural log is expressed as such. It's ln, lowercase l, lowercase n. So the natural log of x is equal to y is how this equation is read. All of the properties and values we've learned with traditional logarithms also hold true for the natural log. So here we're going to solve each equation for the given variable, and we're going to round our answer to the nearest tenth. In the first example, we have the natural log of e to the x is equal to 3. So here we're going to use the power property of logarithms. We're going to take the x, which is expressed as an exponent, and pull that out in front and express it as the coefficient. So it becomes x times the natural log of e is equal to 3. Now it's important to note that the natural log of e is equal to 1. Just like with any log, when we have the base is the same as we're taking the log of, our expression is going to be equal to 1. So the natural log of e is always equal to 1. So simplifying that down, we get x is equal to 3. In the next example, we have the natural log of x plus the natural log of 4 is equal to 2. So here we're going to use the power property of logarithms and condense that to a single log and express it as the natural log of 4x is equal to 2. From here, we're going to convert to exponential form. Remember, the natural log has a base of e, so that translates to e to the second power is equal to 4x. From here, we can isolate the variable by dividing 4 to both sides of the equation, which gives me x is equal to e squared over 4. Now, this is considered calculator-ready form. Plugging this into the calculator gives us an approximate value of 1.85. Next, we have the natural log of x divided by the natural log of 5 is equal to -1. And we're going to use the quotient property of logarithms. Doing so allows us to condense the log into a single expression as the natural log of x over 5 is equal to -1. Now when we convert this to exponential form, we get e to the -1 power is equal to x over 5. And to isolate my variable, I'm going to multiply by 5 to both sides of the equation. And remember, e to the -1 power can be sent down to the denominator, so the exponent can become positive, which gives me x equals 5 over e. And again, this is considered calculator-ready format. Plugging that into the calculator gives me an approximate value of 1.84. In the next round of equations, we're going to solve again, round to the nearest tenth. These are equations in base e, exponential equations that we need to convert to natural log form. So we have e to the x power is equal to 15. So I take the natural log of both sides, which gives me the natural log of e to the x equals the natural log of 15. And we already know that the natural log of e, and we can use the power property to pull that out, which gives us x times the natural log of e is equal to the natural log of 15. And we know that the natural log of e is equal to 1. So we get x equals the natural log of 15, which simplifies to about 2.71. Next example, we have e to the x minus 4 power is equal to 2. And again, we could take the natural log of e, both sides. So we have the natural log of e to the x minus 4, and on the right we have the natural log of 2. Since we know the natural log of e is equal to 1, we can simplify that down and we just get x minus 4 is equal to the natural log of 2. To isolate the variable, I'm going to add 4 to both sides of the equation, which gives me 4 plus the natural log of 2, which simplifies to about 4.69. In our last example, we have e to the x plus 6 plus 5 is equal to 1. So before we start, we need to isolate the term with the variable. So we have e to the x plus 6, which needs to be isolated, so I need to subtract 5 from both sides, which gives me e to the x plus 6 power is equal to -4. Now, since a positive number raised to an exponent will never produce a negative result, this equation will not have a solution. You cannot take a positive number e, raise it to an exponent, and get a negative value. So no solution is our answer to this last equation. So that wraps up our lesson. Please email us if you have any questions, and good luck on the quiz.